Fine, this is Monisha. Today's topic is about edge detection. In these two images, it shows how the edges of the particular images has been detected. You can see a girl only with the edges. It means the goal of this edge detection is to identify a sudden changes or some discontinuity in the images. Intuitively, more semantic and shape information from the images has been encoded in the edges. These are more compact than the pixels. For an artist line drawing, but the artist is also using some object level knowledges to detect the edges which is present in the image. It shows you how these edges has been originated. There is a bottle which has the reflection or a shadow of that particular bottle. It shows how the illumination has been discontinuity, the shape color has been discontinuity, the depth discontinuity, and the surface normal discontinuity. All these are caused by a various factors of this edge detections. This shows you how you characterize an edge. An edge is a place for rapid changes in an image intensity function. For example, the image has some color changes, the pixel has some color changes in the images. This pixel color change has been mentioned in a intensity function along with the horizontal scan lines. Also, the first derivative of this image can also be used to characterize the edge where a rapid changes in the image intensity function has been occurred. In this first derivative, it has been shows the edges corresponding to the extrema of the derivative. We can use a canny edge detector to detect the edges more exactly. This is probably the most important widely edge detector in this computer vision. The theoretical model of the canny edge detector uses a step edges corrupted by the additive Gaussian noises. Also, the first derivative of the Gaussian has been closely approximate to the operator that can optimize the product of the SNR and the localization. Here the SNR is a signal to noise ratio and the localization function. In canny edge detector, we have to filter image with the derivative of the Gaussian. Then find the magnitude and orientation of the gradient. Then we have to find the non-maximum suppression. In this, thin multi-pixel wide ridges down to a single pixel value. The fourth step is linking and thresholding. Here the thresholding mention the hysteresis. It can define two threshold, either high or low. Using this high threshold to start the edge curve, and you can continue them along with the low threshold value. In MATLAB, we can use the command of edge image canny. It means we are supposed to detect the edge in the image by using canny edge detector. It is a MATLAB function. You can install MATLAB and try this on. This is an image. This is the original image of a girl Lena. It shows a normalize of the gradient. The normalization of the gradient for this original Lena image. We can see the edges which is present in the images have been detected. It shows the thresholding. Rather than the normalization of the gradient, we don't have any grayscale values in thresholding. The thresholding means a differentiation between the black and white, the foreground and background separation. It shows a non-maximum suppression like a thinning. It shows you some of the minute edges which is present in the Lena images. Non-maximum suppression means we have a gradient, we have Q. At Q, we have a maximum if the value is larger than those of P and R. If the Q is not from the P and R, we are not supposed to interpolate to get these values. If these are maximum, we can interpolate these P and R to get the value of Q and the gradient. This is the non-maximum suppression. In edge linking, we are supposed to link two edges. In this, assume the marked point. This is a mark point. This is a mark point which has an edge point. Then we construct the tangent of the edge curve which is normal to the gradient and use this point to predict the next step or the next point. Here from this it has either S or R. This point shows you to R or S. Then the topic is hysteresis thresholding. In this we can check the maximum value of the gradient value is sufficiently large. If not, if dropouts, we are supposed to use a hysteresis. In this hysteresis, we can use a high threshold to start edge curving and we can continue them to the low threshold. See here we can start the edge and we can traverse the edge until it ends. If it breaks or discontinues the edge, we can start again. This is the original image. This has a high threshold. Like strong edges has been displayed. It has a weak threshold. Even the low threshold level minute edges of this particular house original image has been showed here. This has a hysteresis threshold. In this hysteresis is the combination of both. It has both high threshold and low threshold, strong and weak edges, but the information here is sufficient for processing the edge detection algorithms. This is the effect of phi. Effect of sigma. The choice of sigma is equal to 1. If it is 1, it can even detect small edges which is present in the images. If the sigma is 2, it can detect only the largest edges which is present in the original images. For example, if the sigma is larger, it can detect only the large scale images. If the sigma value is somewhat smaller to detect or to get the fine features which is present in the original images along with this threshold values. This slide shows you the image and the human segmentation and the gradient magnitude. For example, the original image of 2 has been displayed. The first images, the animal boundaries has been segmented easily by the human and the person boundaries has been segmented by the human. But in the gradient magnitude, even the minute edges which has been displayed in both the images has been identified separately and shows here. Thank you. Let's meet in the next class.